Today our discussion is on power and power factor characteristics of fluorescent lamp. Everybody knows how a fluorescent lamp looks, right? It is there in your home. If you do not have the LED one right now, which are available, uh, we will go back to the fluorescent lamp later. First, power. What is electrical power? It is the amount of work done to transfer Q amount of charge per unit time. You know potential difference or the voltage which is the equal to the amount of work done to transfer unit charge between two potentials, right? That is the potential difference or the voltage V. Now into Q, if the amount of charge is Q and that amount of work done per unit time, this gives you the amount of work done to transfer Q amount of charge per unit time, and this is known as electrical power, and it is given as V into I. Okay, this is electrical power. Now there are three types of electrical power as you have done in your class 11 and 12: active power, reactive power, and apparent power. So this is a power triangle in which the hypotenuse is the apparent power, the base is the active power, and the perpendicular is the reactive power. Now what are active power, reactive power, and apparent power? Active power is actually the power which you can use or which the circuit uses. Okay. Reactive power, it is the power which is being stored in the magnetic circuit of the magnetic energy in the electrical circuit. And apparent power, it is the total amount of power that is being supplied to a system. So you have three types of power. Apparent power, it is the power which is being supplied to the system. Active power, the amount of power which the system uses. And reactive power, the amount of power which the system cannot use, but it is stored in the form of magnetic energy in the system. So these are represented with the help of a right angle triangle where the hypotenuse is apparent power, the base is active power, and the perpendicular is reactive power. Now the angle between active power and apparent power is known as theta, right? So we have another new term. This new term is power factor. What is power factor? It is the ratio of active power and apparent power. Means the amount of power which the circuit uses to the amount of power which is being delivered to the circuit, right? So power factor is active power by apparent power. So we can write it as VI cos theta divided by VI, which gives you cos theta. So you can again define power factor as the cosine of the angle between the voltage and the current phasor. Theta is also the angle between the voltage and the current phasor in a circuit. The angle between the voltage and the current phasor is known as theta, and power factor is the cosine value of that theta. So we have discussed two terms, power and power factor. Now third term is your fluorescent lamp. So how does a fluorescent lamp looks? Let me go to another view. This is how a fluorescent lamp looks like. Okay, it has two terminals on the left hand side and two terminals on the right hand side. Total 4 terminals. Now how does this works? How does this work? You have a voltage source. Suppose you have a voltage source. You have a voltage source of 220 volt. Here we have 110 volt, but suppose you have a voltage source of 220 volts. Okay, now this is positive and this is negative at any instant. AC, this is positive, this is negative at any instant. Okay, so you connect one terminal to this and you connect the other terminal to this. Now, as you must have seen in your home that with this fluorescent lamp, there is another thing which is known as a ballast, or choke, which you call as choke. So this is a choke or a ballast. This is the fluorescent lamp. And another thing you must have noticed in the fluorescent lamp, and that is a starter. That is a starter which is here. This is a starter. Now, the ballast is connected in series with the fluorescent lamp, and the starter is connected in parallel with the fluorescent lamp. Starter is connected in parallel with the fluorescent lamp. This is how a starter is connected. It is connected in parallel. The ballast is connected in series. Let me name them so that you do not get confused. This is ballast or choke. This is fluorescent lamp. This is starter. So this is the common circuit of an fluorescent lamp that is present in our home, right? But when we are doing experiment on this, we need to measure certain quantities. So we need to put some measuring instruments here. So what we require, what are we required to put? We are required to put three types of measuring instruments. To measure the voltage, we require a voltmeter. To measure the current, we require the ammeter, and to measure the power, we require a wattmeter. Now, ammeter is connected here. This is an ammeter, right? This is one ammeter. Voltmeter, you require one voltmeter to measure the voltage across this. You require another voltmeter to measure the voltage across this, and you require another voltmeter to measure the voltage across this. Let me connect them so that it is easier. This is voltmeter. This is ammeter to measure the current. This is voltmeter. This is voltmeter. This is again a voltmeter to measure the voltage across fluorescent lamp.
Sir, you can use the direct line and lines to draw those connections, sir, instead of using a pencil, sir. Sir, you can use the direct lines for drawing those connections.
I know, but that will take time. Do you have any problem with this pencil? Are you not understanding?
No, sometimes they're cutting, that's why I told.
Okay, if you do not understand at some place, tell me, okay?
Okay, sir.
So, this is your basic connection. Right now, where does the wattmeter fits into the scheme? The wattmeter, how does the wattmeter looks like? Let me show you. This is the diagram of a wattmeter. It has 4 terminals, 1, 2, 3, and 4, and 2 coils. This one is the current coil, CC, current coil, and this one is the pressure coil, PC, or the voltage coil to measure the voltage. Now see, this current coil should be connected in series, and this pressure coil should be connected in parallel. So the terminals are, this is known as M, this is known as COM, means common, this is line, and this is V, voltage. Okay, these are the 4 terminals of a wattmeter. If you see a wattmeter, these are the 4 terminals, how a wattmeter looks like: M, L, COM, and C, where M and COM are shorted. Now you have to place this wattmeter here. Now what we will do, we will place the current coil here. See, this is CC, very easy. We have placed the current coil here. The pressure coil we will place here in parallel. And what we will do, we will take a switch here. We will take two lines, one here and one here, and we will have a switch. This is okay. This diagram is just a little out of shot, so let me just tell you how to place the wattmeter. So this is current coil, this is pressure coil. Current coil is connected in series and the pressure coil is connected in parallel. See, this pressure coil measures the total voltage drop across this ballast and the fluorescent lamp. Ballast or choke, it controls the current flowing into the fluorescent lamp. It regulates the current so that the fluorescent lamp does not get damaged due to high amount of current. And the work of the starter is to provide the striking voltage. These fluorescent lamp, they do not glow at 220 volt or 110 volt. They glow at 1100 volts. So in order to give 1100 volt, there is this starter which has a capacitor and a bimetallic strip present inside it, which helps in providing the striking voltage of 1100 volts to the fluorescent lamp. This is the work of the starter and the ballast.
Sir, you have muted your mic.
Sir, hello, sir.
Sir, we can't hear you.
Sir, Sovik says he can't hear you.
Sobik is speaking something.
Hello, sir.
Hello, sir. We can't.
This is the circuit diagram which you have to draw in your lab sheet. Okay, we have used 110 volts 50 hertz supply instead of 220 volts so that any working professional or student may not get harmed. Then we have used a variac. This variac is an auto transformer which is used for stepping up the voltage. So you can get any voltage between 0 to 220 volt as you wish. Now see, I have put a voltmeter there. They have also put a voltmeter there. Ammeter, voltmeter, voltmeter, and this wattmeter they have put here. No issues. You can put where I have shown also. The current coil is connected in series and the pressure coil is connected in parallel. Now see, they have used a switch here. Now this switch is used because see, if the switch is on TOT means total power. So if the switch is on total power, then this wattmeter measures the total power consumed by this ballast and the fluorescent lamp. And if the switch is on CH means choke, then it measures only the power consumed by the inductive ballast or the choke, right? So from, if we subtract the power consumed by choke from the total power, we get the power consumed by the fluorescent lamp. So because we have to measure the power consumed by fluorescent lamp, ballast, and the total power consumed. Okay, so we have used this technique. And second, now what we have to do in this sheet, what we have to do, we have to slowly first increase the voltage. We have to slowly increase the voltage from 0 volt and see when the fluorescent lamp starts glowing, and that voltage is known as the striking voltage, and that voltage is known as the striking voltage. You will observe that the striking voltage is around 220 or 230 volts. Striking voltage is around 220 or 230 volts. Please note down the striking voltage. You are required to write it down in your lab sheet. Okay, so striking voltage is 220 volt. Then what you do, you slowly again come back to 200 volts. We will do 5 readings from 200, 6 or 7 readings, 200, 205, 210, 215, 220, 225, 230. 6 readings, okay? 7, sorry, 7. From 200 to 230, we will do 7 readings. So when the input voltage, see this chart, you have to go for this supply voltage. We will do complete this table for 7 values of supply voltage. One value is missing. You have to write that down. This value is here, I think. Voltage, another table you have to make, another column, and this will be voltage across choke. Voltage across choke. Voltage across choke, or voltage across the ballast, right? Voltage across choke or voltage across ballast. Voltage across choke or voltage across ballast. Another table in between this. So for 200 volt supply, you will get a value of line current, you will get a value of the voltage across choke, value across voltage across fluorescent lamp. Then what you have to do, you have to power, give the power switch, this power switch to total. If this COM switch is on total, then you will get this value, total power consumed, PT, right? And then what we have to do, again you have to change this switch from total to CH, then you will get the power consumed by the choke or power consumed by the ballast, PCH. So you will get 1, 2, 3, 4, 5, 6. 6 values you will get, right? And the remaining you have to calculate. This power consumed by fluorescent lamp, it will be PT, total power minus power consumed by the choke. Then you have to calculate the total power factor, PT, total power, divided by VI into IL. VI is the supply voltage, IL is the line current. Then power factor of fluorescent lamp, only the fluorescent lamp. So power consumed by fluorescent lamp, voltage across fluorescent lamp, and IL, the line current, because the same current is flowing through the ballast and the fluorescent lamp. Similarly, power factor of choke, you have to compute PCH, the value is already obtained. Then VCH already obtained, VCH, voltage across choke, VCH, this new column that I have given, and divided, and IL, line current, which you already have. So you will do this same experiment or do the same procedure 7 times, from voltage 200, 205, 210, 215, 220, 225, and 230. The next step is you have to slowly turn down the voltage, means you have to slowly reduce the voltage, and you will see that at some point, at some voltage, the fluorescent lamp gets off, and that is known as wait a minute, extinguishing voltage, and that is known as extinguishing voltage. That value will be around 140 to 150 volts. You can write it as 145 volts. So the extinguishing voltage is 145 volts. You see, once the lamp has got started, it required 230 to 220 volts to get started, but it is on even if you reduce the voltage, and it is on until 145 volts. When the voltage gets below 145 volts, then the fluorescent lamp gets off. So that 145 volt is known as the extinguishing voltage, So this is how you do the power and power factor characteristics of a fluorescent lamp. Now there are 2 types of ballast. The ballast which we have discussed till now, that ballast is known as the magnetic ballast or inductive ballast. Another type of ballast you have is electronic ballast, right? Another type of ballast which are prevalent nowadays are electronic ballast. Here you do not have the scope for a starter. The starter is inbuilt within the electronic ballast. You have the input, the ballast, the two inputs, the two line currents, the two line terminals goes into the ballast, and there are four outputs, and four output goes to the four terminals of the fluorescent lamp. The starter is inbuilt within the electronic ballast. Now electronic ballast, the power factor is very good. The power factor is very good, and it is lightweight, but it is costly. Okay. Now what we do in case of electronic ballast, what we require to do, we do not have to go for the full table. We have to only do only one row at 230 volts. You have to find out the striking voltage. In similar fashion, you start increasing the voltage, and there will be a voltage at which the fluorescent lamp starts, and that is the striking voltage, and that value is 30 volts in case 50 volts in case of electronic ballast. Fluorescent lamp with electronic ballast, the striking voltage is only 50 volts, and you will take only one reading at 230 volt. You will get the voltage, current, and the power. Okay, you will get only one reading, voltage, current, and power, and you will find out the total power factor, here you cannot find out the power factor of the ballast and the fluorescent lamp individually. Okay, you have to, you can only find out the total power factor. Now in similar fashion, you will now decrease the voltage and see at which voltage the fluorescent lamp gets off, and it will be around 10 volts. Okay, the extinguishing voltage in case of fluorescent lamp with electronic ballast is 10 volts. Okay, so this is how this experiment is done.